Your PC isn't broken. It's just screaming in aerodynamic harmony. That jet engine whine, it's not a malfunction, it's thermodynamics winning. But why does brute force sound so aggressive? Because air is an empty space, it's a viscous fluid, and it fights back. We chase cubic feet per minute. But raw volume is a beginner trap. The real bottleneck is static pressure. Pushing air through dense heat-sink fins requires torque. Low-pressure fans just bounce off the metal. High-pressure fans punch through. Which one are you actually using? You want silent. Sure, buy a bladeless turbine that moves air like a sleepy sloth. Efficiency drops, temps spike. You traded thermal headroom for a library nap, but silence isn't free, it costs latency, and latency kills performance. So how do we fix the lag? Bearings. Fluid dynamic bearings whisper, but they bleed oil over time. Ball bearings clatter, but they handle torque. Sleeve bearings. Don't get me started. They fail when the GPU hits gigahertz. Which one survives the thermal cycle? Bearing choice dictates lifespan, but lifespan means nothing without control. Enter pulse width modulation. The brain, it doesn't just spin faster, it modulates duty cycles, 19.7 kilohertz, ultrasonic. Your ears hear the blade pass frequency. Your GPU is doing calculus. Calculus hits physical limits. High RPM means structural stress. Centrifugal force tears cheap plastics apart. Loud fans use reinforced ribs and aerospace-grade polymers. They scream because they're built to survive the thermal throttle. But why do they vibrate? Vibration is just resonance waiting to happen. Silent builds dampen it, but dampening adds mass. Mass kills acceleration. PWM needs instant response. Heavy fans lag. Lag means heat buildup. Heat means instability. We choose noise over instability. Every time, so you blame the fan? That's a skill issue. You're bottling your own CPU. Thermal throttling isn't a bug. It's a feature of weak airflow design. Stop blaming the noise. Blame the mesh. Blame the case topology. Loud fans don't apologize. They perform. Performance requires geometry, optimized blade pitch, twisted geometries, vortex shedding minimized. Engineers spent thousands of hours perfecting that scream. You call it noise. I call it peak aerodynamic efficiency. But what about the acoustic footprint? Acoustic footprint is a trade-off. Dampening absorbs sound, but it also absorbs energy. Energy loss means wasted RPM. Wasted RPM means thermal compromise. We accept the decibels because entropy loses when airflow wins. The whine is just victory. Victory requires proof. Drop your RPM curves in the comments. Show me your thermal gradients. If your silent build hits 85 degrees under load, we need to talk. Loud fans don't apologize, they scale, and scaling is everything. Scaling means longevity. 1995 builds lasted decades. Why? Because they respected physics. We're not here to whisper. We're here to move air. Keep the fans spinning. Keep the temps low, and never apologize for the roar.